Good morning, everyone. A warm welcome to all our respected dignitaries, our faculty members who have participated in our FDP for the day 3 of our faculty development program. We hope you found the sessions over the past 2 days both informative and enriching. As we continue this exciting journey of learning, today's session are designed to explore the transformative role of emerging technologies in healthcare and research. I am confident that today's session will provide valuable insights, practical knowledge, and hands on understanding that will further enhance your teaching, research, and professional development. Without further ado, let us begin our first technical session of the day. It gives me even immense pleasure to once again welcome our esteemed speaker, Dr. Richa Gupta, Assistant Professor, Department of Computer Science and Engineering, School of Engineering, Science and Technology, Jamia Hamdard, New Delhi. As ma'am was formally introduced on the first day of our FDP, I will keep today's introduction brief. We are delighted to have her back with us today to continue the sharing her expertise and insights. Today's session topic is machine learning, IoT, and big data in public health and food system. We are honored to have ma'am to guide us through this fascinating and highly relevant topic. Without further delay, I invite ma'am to begin today's session. Good morning, ma'am.
Good morning. Thank you so much again for the introduction and for inviting me again. Thank you so
Welcome, ma'am.
much.
Welcome.
Uh, I hope I'm the co-host and I can share.
Yes, ma'am.
My screen is visible.
Yes, ma'am.
All right. Okay. Good morning, everyone. So last time we have discussed about machine learning in detail. What is machine learning? What are the different uh, variables, the features? There, of course, there are a lot of food securities to be taken into account. So good food system is very important to maintain, right? So to start with, what is machine learning? As we have also understood this on the opening day, that it is, of course, a subset of artificial intelligence, which focuses on training the computer algorithm to recognize patterns and make prediction from data without being explicitly programming. Now, machine learning, as just told you, it is the subset of AI, and further, there are other techniques which we study, like deep learning, which is the subset of machine We have already seen that supervised learning are categorized into classification and regression. Classification, where we have a very crisp answer of either we can classify the given data set into a specific label, like either if I want to buy something, whether I want to buy yes or no, right? switches on or off. There is no intermediate data in between or output in between. While, on the other hand, regression, which is again a type of supervised learning algorithm, works in between data also. So there is a range of outputs and different algorithms which have been classified as classification, and further also in regression there are a number of algorithms. Next, we have also seen what was unsupervised learning. Under unsupervised learning, we had clustering, dimension reduction, and associate rule learning. In clustering, we have seen how we can cluster, and we are not given a label data point. We are given Hmm. Acha, acha. Let me log out and log in again. I think, है ना? हाँ हाँ ठीक है. हाँ जी. Maybe.
Everyone, ma'am is rejoining shortly. Please wait.
I have joined. Am I audible?
Yes, ma'am. Yes, ma'am.
Thank you so much. I don't know why this, because I'm sitting in the exact vicinity of internet connection, just in the server room, and still the issue is going on. All right.
Ma'am, please
So
share
I
your
can,
screen.
yeah. All right. So coming back that to the supervised learning. Now the next one is unsupervised learning that we have already discussed in our last session. That is clustering, dimension reduction, and associate rule learning. While we are talking about clustering, we discussed that clustering is something where we do not have any labels defined with our data points. So just looking, we can say whether it is one kind of object or not. So if we are given a pile of, let's say, 20 objects, We can categorize them, cluster them, looking at it that, okay, if their color is same and their shape is same, we can categorize them into one cluster. So that is clustering. No previous training is given. What we see, we cluster as per what we are getting the data, looking into the features. So next was associate rule training. In associate rule training, we discussed about if-then rules. That if you remember, we discussed about the shopping and the market area. That if a customer is buying one product and it goes for 10 different customers, that if we the 10 different customers are having, let's say, bread, so they are automatically buying the milk also. So this kind of if-then rules we saw under associate rule learning. Then we had also seen dimension reduction. In dimension reduction, we discussed about how one after the other we keep reducing the data set and we come up to the actual data, right? Okay, if any shape, is it square? No, it is round. Then so categorize into all right, coming back, and it is lots of issue right now. I don't understand today. Okay, so next we have a reinforcement learning. In the reinforcement learning, we discussed about how the if on the basis of rewards and the penalties we give, whether the data is correct or not based on the given features, right? So whether we are having a correct data, we do not have a correct data, if you're moving in a correct direction, then in that case you are awarded and you move ahead, right? But if you are not from a given data set, if you're not having a uh, correct answer, right? So for that, you will be penalized. So the reinforcement learning based on award penal, right? Awards are there if you for a given data set you are having a correct output. We also discussed about the something like if you remember features, labels, and bias, variances, over
Uh, Ma'am, is my voice is audible to you?
Yes, it is well audible. Please
Good
proceed.
morning, sir.
Yeah, very
Uh, I would like to ask with Dr. Richa, ma'am. Is my voice is
good
audible?
morning. Very good morning, Dr. Sharma.
Dr. Akhil, Dr. Akhil, Dr. Akhil.
Yes, sir. Yes, sir.
Yeah. I think many people have,
I'm back.
around 61 people have joined.
Yes, sir.
So now we can proceed.
Sir, we have already started, but ma'am have internet connection issues, so we are resolving it.
Yeah. Okay.
Okay, sir.
So, okay,
Yeah, please.
starting, yes. Thank you so much for the patience, and I apologize for the poor internet connection.
No
Uh,
worries, ma'am.
Yes.
model, starting from the very first, that is data to be collected, and then the pre-processing of the data is done. Then out of it, we do the feature selection. Then we split the data set, and then we split the data set into training and testing. And then we choose the algorithm. This algorithm at any given point can be
सॉरी मैम बट आपका नेटवर्क अभी भी सही नहीं चल रहा है
visible. Still.
मैम स्क्रीन इज विजिबल बट योर वॉइस इज कटिंग
चलिए ठीक है सर. All right. So let's start with these are the ML machine learning in public health. What could be where the machine learning can be used in public health? It can be used for prediction. We can do the we can use the machine learning for epidemic and for pandemic surveillance. Again, we can use the machine learning approaches. For medical health analysis, we can use the same. Similarly, for personalized healthcare, hospital resource management, we can have all these kinds of machine learning algorithms which we have seen so far. Moving ahead, now where the machine learning can be used in food systems. In the food systems, we can use it for food production. We can use it for precision agriculture, crop disease detection, for yield production, then food quality assessment, then crop disease detection, which is nowadays very much in demand, that how the crop detection takes place. Lots of apps nowadays are being developed over this, that how the disease can be detected in the various crops. Now, moving ahead, since we have already studied about ML, let's move ahead and we get to know now what is IoT, that is Internet of Things. So Internet of Things is a network of physical objects like various devices, vehicles, appliances. Basically, IoT is something when we talk about IoT, that means we are actually talking about the various actuators, we are talking about the sensors. So when we are talking about the various sensors, that means what is the purpose of using sensors? The main purpose of using the sensors is that to collect the data. Now, how we are collecting the data, that is important here. If you can let me know, am I audible or not?
Yes, ma'am, you are audible now.
Thank you. And my screen is visible, right?
Yes, ma'am. Yes, ma'am.
Just let me know in case it is not, please.
Yes, ma'am.
Thank you so much. So, Internet of Things is the physical objects like devices, vehicles, appliances, where you're embedding the sensors, and those sensors are interacting with various softwares which collect the sensor data and have the network connectivity. So what it does is it collect the data and share it. So in generally, when we talk about Internet of Things, things is something non-living. So we are talking about the objects which are connected with the internet and they are collecting the data set. So they are collecting the data. And this data is then moves towards the respective devices, especially the servers, where the various softwares are there and which helps in doing the analysis, right? For example, say if I give you an example of cars with a sensor, and now the sensors can only sense the data as its owner is coming towards it. It has to open the car gate, right? So it is a work of a sensor that it collects the data point of that human, of its owner, and then if it checks whether sensor collects the data, it will send to the server. Server will cross-check with the owner's data points which are already available in the data set. It will cross-check, okay, this is the owner. It will send back that data to the sensor, and then the sensor will command the gate to get open. So as the owner comes near to the car gate, the gate gets open. So what is happening here? The different sensors, the actuators, which are collecting the data, they're sending that particular data to the server, which is further analyzing that data. So what is happening? That every moment we are increasing the data set, right? सेशन चल रहा है सर अभी इन कंटिन्यूएशन चल रहा है all right, why it is important, why is IoT so important to us? That is very important, right? Because we are collecting every now and then lot of data. So we can have it manually. We can open our car gates manually. But why we are doing it with the help of sensors? What is the need of it? This is because nowadays we are moving towards internet. Everything is going over internet. We are making it smart. So we can connect everyday objects. Now you can hear about that. We usually have smart AC, smart geysers. Everything is going over the mobile phones to connect our all everyday objects to our mobiles, to our softwares. We are making everything smart. Smart appliances, smart cars, smart thermostats, whether it's baby monitor, keep at one place and you can observe the baby from the another room. So, to the internet via various embedded devices, which can help in seamless communication between the people. That is why I need IoT. Why? Because everything is now on the mobile. You have your mobile in your hand, you have everything in your hand, whether it's your bank, whether it's your home. So everything gets into your accessibility. You don't have to wait. Oh, it is so much summer heat going on, and I wish as soon as I reaches home, the home should be cool enough that I need not to wait for it. That ACs first should get switch on, then it should cool the home, and then I can relax. So instead of that waiting period to get reduced, what I want that some accessibility should be there, so I can do the things seamlessly. The communication between me and the relaxation should be very seamless. So what we are doing is we are connecting our mobile with that or connecting our smart devices with the everyday appliances, right? In fact, with everyday requirements. So that is why we need the IoT. And IoT is basically where we are having the where we are connecting the data, right? Collecting all the data through various components. So what are the key components of IoT? First are the devices from which we are collecting the data, like smartwatch, sensors, cameras, medical devices. Drones nowadays are collecting the data. Then various home appliances where you want it to become smart. Then the sensors which are inbuilt into it, which are embedded into it to measure. Why we need sensors? We need sensors so that various physical parameters can be measured, like temperature, like humidity. If we go to medical devices, BP, oxygen rate, then oxygen rate, then heart rate. If we go to the this agriculture, then for we need a weather uh, conditions, soil moisture, air quality. So for all this, we need sensors to collect all these parameters. Then connectivity, because the sensor has to send this data to the server where the analysis will take place. And this has to be done in real time. So for that, a proper Zigbee, then Zigbees are the specialized IoT connectivities are there. Then LoRaWAN, and these are all specifically for IoT systems. Then Bluetooth, Wi-Fi, 5G networks, Ethernet, all these provide you the internet connectivity. With the help of these, we can get connected to the internet. Then cloud platform that will store your data, that will do the data processing, and are connected with the devices directly. And cloud, when we talk about, you all have heard about the term cloud computing, cloud is here, cloud is there. So what exactly is a cloud? Cloud is not something which is hardware which you can touch. It is just a concept, right? It is a concept which helps in providing all kind of data, which helps in storing your data, and which provides all the analysis on that data as per your requirement. And it works on a very simple technique, that when you want the uh, processing, when you want the data, you get the data at that time. Wherever you want, you get there itself. And how much you want, you get that, right? So you can access your data from anywhere, anytime, and any amount of data. That is what cloud platforms are providing, right? So you must have heard about Amazon Cloud, then Google Cloud, which we all, in fact, are using. Yes or no, but yes, in some part, we are also using a part of clouds, right? We are not going in detail what is cloud platforms. Then is data analytics and AI. Now, whatever the data you have collected, it would be in different manners. If we are collecting from different sensors, and of course, the sensors may be of not of universal format in collecting the data. So they are collecting the data in different formats, right? They can detect the patterns. They can make the prediction with the help of analytics software, data analytics software. So data is getting collected. They will generate and will look into the various patterns in the data set and will make the predictions accordingly. Like, for example, if there is a medical device which has a sensor, and the work of a sensor is to collect the continuous blood pressure and heart rate. This data will go to, let's say, hospital server, because this all is happening at the hospital. So hospital server is collecting all this kind of data. And then, so this device which is collecting this data, and the server is connected via Ethernet, via Wi-Fi, and the data in the server is getting stored, because server capacity is limited. So we need something called, we say it, cloud platform. So data we are storing there. There are the softwares for analysis. So we take these kinds of data, heart rate, BP, and then the analysis have to be done whether the patient is fit, fine, or needs some medical attention, right? So these kind of analysis, that is the labels will be provided, and this data will flow, let's say, to the nursing station if a patient needs a urgent help. So for that particular patient, nursing station will get a beep, oh, this patient needs the help, and that will be clicked on, right? Then we have different applications, um, like wherein become user friendly, all this thing. You don't have to look out where are my sensors, how I have to look into the connectivity, where is a cloud platform. As a user, we never look into all these aspects. But yes, the one who is designing these kinds of apps, they will look into the sensor connectivity, cloud platform, data analytics, and AI, everything. So the applications which are getting designed every day, like mobile apps or control system. So all this helps the user to have a good UI UX. User can very easily have a good interface. They can very easily interact with the software, right? So these are the very key components of IoT. But as a user, we never look into it, but the manufacturer look into all these things. How IoT helps in the public health and the food systems? So IoT can enable the continuous monitoring and the rapid response by whatever the data is getting collected by the sensors. And when they have to give a rapid response, this is only done when a data is collected and the analytics has been performed on it. If I take an example where the IoT has been implemented so far as the wearable health devices, we use Fitbits, we use smartwatches. Any smartwatch, they have the various health apps also. Inbuilt health apps are there which continuously monitor your various parameters. In fact, to maintain our wellness, what we do, we set the steps to it, right? So wearable health devices are there where the IoTs, how they're collecting this data, that heart rate, blood pressure, glucose level, oxygen saturation, how they're collecting all this data, because that wearables have the sensors which are touched with the skin, and through the skin they are collecting all kind of data. So there are nerve endings, as you all know, that there are the nerve endings on the skin, so through which are getting connected with the sensor, and the data is getting transferred through that sensor to the server, right? Then we can have the environmental sensor, which will help in monitoring the air quality, which we generally see that what is the air quality of any respective state. That quality is being gathered by the sensors itself. Similarly, for the water quality, we have a sensors. So these can be categorized for the IoT. Now, this is one of a very good example. In fact, I myself has used this for my research work also, that thought control computing, wherein this is a NeuroSky's, the headset which the lady is wearing is a NeuroSky is a company. They came up with their product Mindwave. And this, yes, the IIT have this product. They captured the data through this NeuroSky product. So they have the, if you see the one handset which is touching the forehead, it has a sensors. So it is collecting the EEG data, that is the brain wave from the fore, forehead part of our brain. This is, that we call as forebrain. Similarly, there are different sensors on the different part of this what you call headset, right? And what it does is it collects the EEG data, and it has been seen by this product that they have used this EEG data set, and how a mind can control a toy car while moving it, going forward, backward, and likewise that. In fact, the Stephen Hawking sir has also came up with this idea of that how a neurons and neuron capability can help a person who is differently abled, right? So this is all what is happening here is the various devices which are connected to the skin. They are collecting the type, they have a inbuilt sensors into it. Those sensors are actually transferring the data which they have collected to the server via cloud computing, right? Cloud computing concept. And at the server end itself, you have the various softwares which do the analysis, and what should be the correct output gets transferred back into this what you call sensors on the headset, and is then sent back, right? So this is how this communication takes place in this NeuroSky product between the EEG and that toy car. It has been seen. You can see on the YouTube also. They or on the NeuroSky site, if you open it, they have very nicely explained this product also. So this is about the IoT. Now, big data. Big data, as the name suggests, is too much of data. The data is very big. So that means your data is extremely large, it is complex, and it is generating every day. And we all know, if we are using social media, and we all use social media, whether it's a WhatsApp, whether it's Instagram, Meta, Twitter, every second, a new account is getting added. And every second, billions of data, trillions of data, in fact, is getting added, right? So the data is getting expanded, it is getting large, it is getting complex. Why complex? Because I don't know what is the universal data which other person can understand. I am writing in my own language. Maybe it can be some encrypted language. Maybe it is some, let's say I'm writing in Hindi, but the other person understands in French, right? So this, there has to be translation. I have shared my WhatsApp chat, let's say, on Hindi. It will get, so the server will have a kind of data in Hindi. It will translate into French, right? So analysis is there, and it will then convert into French. So on a server, Hindi is there, French is there, and that data will be sent to the across the person whom I am communicating with. So there is lots of complex data and rapidly generating data sets are there. Two people who are communicating may be communicating in, let's say, emojis. They can understand what that language of emoji they have designed for their, let's say, secret writing or crypto writing kind of things. But the other person cannot understand. So what is they are doing? They are adding to the database, right? So this is data is getting added in. More and more data is there, which is complex also. Now, can what the big data is doing, we cannot be efficiently collected, stored, and processed and analyze any traditional data. These big data cannot be easily collected or stored or processed and analyzed by any management tools, right? Which have been traditionally used so far. Let's say Excel sheet, if you say. So Excel sheet is not capable to go till infinite as the big data is getting collected every now and then. If at my, let's say I have a server, I know I'm collecting a, let's say Facebook data, metadata. So I'm collecting that data and it is, I know every second the data is getting increase, and it is getting trillion. I'm using Excel. Excel cannot hold that much of data, right? So I need some other tools which can hold, which can store, which can process, which can analyze these kind of big datas, right? We need other kind of systems for this. So there are big data architecture is entirely different from our traditional system. For traditional system, we use tables, we use Excel file, but for the big data, we use another architecture like Hadoop, right? So there are number of other architectures for the big data we specifically use for this purpose. Now, the another problem which comes is why we need big data is because the data which we are getting can be structured, it can be semi-structured, it can be unstructured, right? A user can provide any kind of data. If you're writing any, let's say, vlog, then that vlog can be in very well written. So you may categorize into structured data, but some vlog may be written in vague way, right? Some phrases are there. There is no formatting at all, but you can still understand. Then that is unstructured, absolutely unstructured data, right? Then that means that can have a text, that can have a video. So what you want to convey is actually conveyed to the user, other person, to the receiver, but it is not in some format, unstructured. Semi-structured, something is very formal, something is very informal. So that is semi-structured data. So we are having nowadays every kind of data, structured, semi-structured, unstructured, which cannot be understood by traditional management tools, right? So let's say if you have if your data set you have defined in Excel sheet, even if it is a mobile number, and you have defined that cell value very less, you see the mobile number, or in fact, if you're putting the amount into it, any, let's say money amount you are writing, and it is many zeros, it will take into e raised to power something. If a person is does not, if a layman does not have any knowledge of e value, exponential value, they won't be understanding that what is this amount refers to. So for them, it is very important that this should be explained very well, right? The number should be written in such a way that the other person can read it properly, right? So these are the five big characteristics of big data we generally study and which comes along with big data, right? And we call it as five V's. First, volume. Why? Because we are getting, why volume? Because every now and then a lot of amount of data, huge amount of data is getting added, and that is why it is called big data. Second, velocity. The speed of data generation is very high, very high. The moment we are having this session, in this session of 1.5 hours, a lot of trillions of data has already been added into the servers, right? So velocity is quite fast. As I'm talking to you, we are connected via internet, but still there are sensor. The camera is there, which is capturing every moment of mine. So camera is having a sensor. That is why you're able to see me via connectivity also, right? So there are IoT devices which may, if I'm moving my hands while I'm speaking, and there are sensors around, so they are capturing every second of data. There are nowadays everywhere CCTVs are there, which are IP built, right? Internet is connected to them. So CCTV is all having a sensors which is collecting the data of every second. So you can understand that what is the speed of a data generation nowadays. Variety. Variety because it's not that we are having a text data, now we have a image data, we have a video data, we have medical data, we have medical records, you name anything. You have that kind of variety into the data set. Then is veracity, that is data quality and reliability. We anyhow, when we are talking about the data set, we are sometimes having incorrect health records. We all know when there is a lot of data, we sometimes say, oh, there is a duplicate of data is going on. There are some incorrect health records which are there. You tend to change. We ask the government authorities to please get it corrected, right? Because some record is uh, uh, wrong, incorrect, right? Or there is a duplicate because let's say if I have a bank account in, if I have accounts in two different banks, so I would be storing, giving my PAN card, my Aadhaar card to both the accounts. Both are saving my data, and when it is uploaded at a server, at a central server, then my data is getting duplicated because both the banks are saving the same Aadhaar number, saving the same PAN number, but of course they have a two different account numbers. One may be from SBI, one may be from Axis, right? But they both are having the same. So they are duplicating the data. Then is a value, useful insight from the data. That is very important. That means just correct analysis on the big data is very important so that you get to know, you actually know what is this application about. If there is an outbreak of a disease to take place and your sensors has collected the data, it can predict, yes, this would be the further prediction, this will reach to an outbreak or not, or is, it will be confined to a very small geographical area. Then crop yield. When a sensor is collecting, let's say, weather condition, continuous weather condition, and the soil moisture is there or not, right? It is continuously sensing. So it can predict whether the crop yield will be good or not. So value should be given, should be provided when we do the analysis of a big data. That is why these 5 V's are always taken into picture when we talk of big data. Now, as I just told you, there are types of big data, that is structured, semi-structured, unstructured. So structured, when we talk about, that is we have divided into normal tabular form, and we have rows, columns, and we can store our data set. Just like in hospital databases we have, wherein they store all kind of patient records, right? And what maybe the private room or semi-private, general wards kind of data, which is free, which bed is, if any room is free or not, any beds are free or not. For patient data also, which patient is on which bed, in which room, in which department. That means whether it's a heart department, orthopedic department, likewise, whether they have been operated or not, is there any operation date which has been given to the patient. So all kind of this is a structured data which is maintained by some which is maintained by a party, maybe third party also. So hospitals are maintaining, they have put it in a structured way so that the retrieval of a data becomes easy. Now, when it is a semi-structured data, that means it's partially organized, and we generally use tags, we use metadata. What is metadata? Metadata is data about data. That means when I'm writing an email, so that itself is a data, but what is this date? What email it is about, whom I'm addressing. So what it is, there was a data, email is a data itself, right? But when I'm addressing a questions like whom I'm sending this email, who has written the email, what is this email about? So these kind is called metadata. That means data about data, right? So when we are using a partially organized data like emails, right? In that case, it's a semi-structured. Why I'm saying semi-structured? Because while writing email, you always have to, then we have from and to is always there. Whom to send, from where it is coming. If you want to add CC, BCC, and subject, this is already structure of a data. But what you're writing in a body is not structured. You can have any kind of data. You can write anything which what you wish in any of the format. You can make a attachment if you wish, right? So that becomes a partially organized. No one can guide you, can supervise you. No, no, no. In the body of a email, you can write only this thing, right? So that is why it is a semi-structured data. Unstructured data, you have absolutely no predefined format, like when you have a social media post, like the various formats of the videos we get. You can have MP3, you can have MP4. So if I'm communicating to someone, sending a data, maybe I'm having MP3, other person is not having it. So I'm sending an MP3, but there is no predefined communication that, okay, the two parties will be communicating on this format only, right? So it's no predefined format is there. Medical images. Maybe I am saving the image, medical image as JPEG, but the other one is saving as bitmap, right? So that is unstructured data. Now, these are the sources of big data. What are the different sources of big data? From where we can have all these kinds of data set. We can have from healthcare, we can have from public health, we can have from different food systems. So what from where we are collecting? These are just from the public health and food system point of view, but otherwise we can have the sources from different places also. You know, we are collecting, as I just told you, as I just told you that you are collecting the big data from different sources, from especially from the social media, right? So these are in perspective with the current topic of the FDP today. Healthcare, that is electronic health records. We already have, government have their now health records where you can put in your data, your any previous prescriptions are there and something like that, and that you can upload it. And then wearable devices, as we just discussed, there are number of wearable devices which we are using also, but in the hospitals also there are other wearable devices, medical imaging. Then laboratory reports we have, because from one laboratory to other laboratory you go, your reports value tends to change, right? You always see if you do it from path lab or you move from Dr. Lal paths. So the report values of, let's say if I'm having this RBC count, right? It will tend to change. Then genomic data, of course. So genomic data will be changing from one person to another. Maybe I'm working on one chromosome, other one is working on other chromosome, the DNA count, then maybe disease related thing. So genomic data will add up to the big data also. With respect to public health, we have disease surveillance system so that we get to know that whether this particular disease will reach up to the outbreak or not. Vaccination database, because vaccination database is very important just to know whether a country has eradicated any particular disease or not. Just like the polio, we say now the country is polio free, right? But still there are cases, there we see the cases, but vaccination database helps us to know that at which level we are now, how much percentage we have eradicated any disease. So of course, this database will add up to the big data. Environmental monitoring, just for the crops I told you, for prediction agriculture, precision agriculture, crop predictions and everything, based on the factors it is taking. Social media, we all know that. Census data as it is nowadays getting collected. So it will, of course, in a country like ours, which is having 180 uh, uh, crore people, then in that case, of course, a lot of data has would be there, of course, right? So this is another source of big data. In the food system, we have IoT sensors, where in the manufacturing we are doing, and it is getting stored at some warehouse. So what are the parameters, what sensors are reading, what are the parameters in that warehouse, humidity, what is the air quality. So all this data, the sensors are reading, and it can get us know that, okay, is the parameters correct, and the food or the grains which have been saved or which are being stored will be safe or not. Then we have weather stations, of course. This is very common that every moment the sensors at the different places which have been put by the weather station people, they are collecting the data continuously to forecast beforehand and predict what could be the weather in next 24 hours. Now we even have a data for next 15 days also, right? Drones. So drones nowadays are connected with internet, and they take the commands from one place, and you can fly the drones at another any given place. And nowadays even the drones are delivering the goods also, if you have seen. So there also they are a source of continuous big data, satellite images, supply chain records, smart farming equipments. All this add up to the sources to the big data. So now we now get to know what is ML. We got to know what is IoT. We got to know the big data. But it is very important to understand that these individually never work. They work together. So what happened first is IoT. IoT is going IoT sensors and actuators. The work of them is to collect the data. So they are connected with various variable or any application which we are using. It will be then from these sources where the sensors are there, data is collected and will be sent over the cloud storage, where the data is securely stored and in the cloud for the scalability for easy access. Now comes the next picture. Now the data you have collected from the various sensors, it is it can be semi-structured, it can be structured, it can be unstructured data, but of course it is in a huge amount, right? And it cannot be processed by the traditional methods. So we need the big data analytics here. We need the tools and the architecture of big data. Just I told you Hadoop systems, which actually look into the big data architecture analytics, right? So they take in this data, this architecture at the and this Hadoop system is actually over the cloud itself. They take in this kind of data, they process over this, and all the analysis software are over the in the Hadoop system over the cloud, right? So they take all those big data in any form. It is having the data, whether structured, semi-structured, unstructured. They analyze it, they process this large data. And when we are using this kind of
Sorry, ma'am. Ma'am, your voice is breaking again.
those prediction, we are saying, okay, there will be a disease outbreak. So based on those outbreak, so we have to take a decision that, okay, there has to be some, let's say if there is a, we have seen already uh, during Corona times, if all those have been forecasted earlier, a prediction is done, okay, there will be outbreak. So decision can be taken beforehand. whether you have the person or that geographical area has to be quarantined within a limits. It has to be bound. There has to be boundary. There has to be lockdowns or not. So this is a decision which has been done on the basis of the prediction which came up with. Okay. And then the further, of course, decision is taken, and the people, disaster management people, or the ones who are actually into the implementation level will take the timely actions to control it, to improve the health situation, or to for any prediction we are making. For that, they will take a timely action. So this is how IoT, big data, and ML work together instead of separately. They cannot work separately. They all three work together to have a successful application, right? This is just a small example. We earlier the Fitbits are there. In fact, nowadays also Fitbits being used, wherein we can see whether my sleep is good enough or not. What is the sleep pattern? To just look into it, it this Fitbit is taking the sensor. It has the sensor. It collects the data when you went to the bed, when you fall asleep, right? So through your skin sensors, it is that has a nerves ending. It collects the data and it process all the things, right? And it gives you the answer whether your pattern is good or not only after doing the analysis, which is being carried out at the server end, right? Plus, it can give the sleep stats. Now, what happens is Fitbit, of course, is not going to display everything. You are going to connect it with your mobile app, and your app which or this Fitbit has a sensor, it is collecting a data, it is sending to your app. And at the app itself, it is analyzing all this kind of data and is giving in a form which user can understand. Like how many the time is sleep over the past 30 days in hours, how much you have woken up in which day, how many times, right? Whether you had a 8 hours of sleep or not, so all kind of data it will display, but in your app itself. But the app can only analyze with the data it has collected from the sensors, right? So how it helps in public health and food system, these are that the combination of IoT, big data, and ML collectively, how it helps in public health and food system. These are the different applications, few application where it can be helpful. That is outbreak prediction, any disease if there is, then cold chain monitoring for the food safety for any perishable goods from spoiling of the food. And if there is any risk of food poisoning or so, then precision agriculture, wherein it checks into whether the water flow is there or not into the fields. If not, and the water needs to be flown into the fields. So with the help of a sensor, it goes to the tank, and the tank or the tube well, and the tube well starts operating and the water flows into the fields. So while doing the precision agriculture, and of course the rapid traceability where you have the uh, any contaminated foods which have been dispatched by some batch and you want to traceable. So with the help of these techniques and this architecture together, we can also do this when the health hazards can be minimized, right? These are few of the application, not all the applications, few of the applications which we can have it, right? This is all for this session. I'm open to the questions, if any. Thank you so much for patient learning and patient listening.
Thank you so much, ma'am. We do not have any question regarding today's topic, ma'am. So we proceed further.
Okay,
Uh,
thank you
Thank
so
you so
much.
much, ma'am, for such an enlightening and engaging session. Your comprehensive presentation on machine learning, IoT, and big data in public health and food system had provided us with valuable knowledge, and we also get to know how emerging digital technologies are transforming the healthcare. Uh, your expertise and thought-provoking deliberation have greatly enriched our learning experience. We sincerely appreciate you for accepting our invitation to join us and taking the time to be continue with us today. As a small token of our gratitude and appreciation, we are pleased to present your certificate of appreciation and a virtual memento. These tokens of appreciation will also shared with you shortly. This is the certificate. And this is the virtual memento. Once again, thank you so much, ma'am, for your gracious presence, your valuable time, and your excellent session. We look forward to your continued association with us in the future. So, thank you so much, ma'am.
Listening, and thank you for inviting me. And all
Thank you
the
so
best to
much.
all the participants.
Thank you, ma'am. Everyone, we are going to start our next session. Please wait till our next session will start. Sir is joining soon, so please patiently wait till then. Sir is joining us. Everyone, sir is joining us at 12:30 p.m. So we are announcing for the break of 20 minutes. We will rejoin at 12:30 p.m. Hello, sir. Very good afternoon.
Hello, good afternoon, ma'am.
सर स्टार्ट करें हम?
Yes, ma'am.
हाँ ठीक है सर, क्योंकि एक बार कनेक्शन भी देख लेंगे सर हम।
ठीक है, ओके.
Everyone, I want to welcome you again. We now move on to the second technical session of today's faculty development program. It gives me immense pleasure to once again welcome our esteemed speaker, Dr. Naved Alam, Assistant Professor, Department of Computer Science and Engineering, School of Engineering Science and Technology, Jamia Hamdard, New Delhi. Sir was formally introduced on the first and second day. I will keep today's introduction brief. We are delighted to have him back with us to continue sharing his expertise and enriching our learning journey. Today's session is on the topic statistical inference and hypothesis testing using Python. We are truly honored to have Sir with us once again to share his valuable knowledge and practical experience on this important topic. Sir, please join and start.
Yes, thank you so much.
Sir.
So good noon to everyone. So I'm not giving today introduction because we have already conducted two sessions. So okay, now first I'm sharing my screen. Please check that.
Yes, sir.
Is that visible?
Yes, sir.
Okay, so we are starting the topic related to the statistics and using Python, and we will choose some data for performing the statistical approaches on that data. So first introductory session, we will see that what we can do. Like we are having some raw protein sequences or maybe some bio
Sir,
Python and amino acid combinations. Yes.
sir, please go for the slideshow mode.
Okay.
Done, sir.
Okay. So in statistics, there are many approaches that we can use into the data understanding and getting the knowledge from the data and get insights into the data. So we can see that we will be having these things like Z test, T test, and fear like ANOVA, and we will be applying these things to understand how the data will be showing the result in terms of these approaches. So in terms of statistics, like if we want to understand the basic of statistics we know that it is related to the data, and that data means like we are having some information, and that information can be in the form of any parameters. So they can be defined. We can define the statistics terms in terms of descriptive statistics and inferential statistics. So statistics we can use for measuring the central tendency and measuring the variability, and also we can represent the graphs into the descriptive statistics. And into the inferential statistics, we can conclude some remarks from the data after conducting the experiment. And here we can get the outcomes in terms of probability distributions and hypothesis testing, regression analysis, and confidence interval. So in the measure of central tendency, we will see that we will be able to calculate the mean value, mode value, and median value. So mean, we know that it is the sum of average of all the values divided by total number of values. And mode, we know that that is the frequency of numbers that comes. Median, that we know, that is the range of value divided by 2, like one first plus second by 2. Okay, and measure of variability, that range means like higher value minus lower value. Variance we will see in terms of mathematics also, and standard deviation and interquartile ranges also. Graphical representation, we will be able to understand or visualize the histogram plots, box plot, pie charts. So in the statistics, there is also the part of probability distribution, and we can see different types of probability distribution like discrete distribution, okay, and continuous distribution. So in the discrete distribution, there can be a Bernoulli distribution, binomial distribution, uniform distribution, and Poisson distribution. And into the continuous distribution, we will be having normal distribution, chi-square, exponential, logistic, and t distribution. Okay. So, like we can also perform the EDA on the data set in terms of univariate, bivariate, and multivariate analysis. And in the univariate analysis, we are having or on analyzing the data in terms of single variable. And like suppose there is a frequency of the data, and then there will be a value, how much value of that, how much of that data is occurring at what frequency. So we can show such type of thing in terms of plots, and these plots can be a bar plot, and this is showing the distribution of the data, how the data is distributed through that bar plot. and what is the central tendency of that data, and what are the outliers that we will be able to see through that data. And into the bivariate analysis, that is the analysis between the two variables. Okay, so we will be able to identify the correlation. Correlation will give you the degree of similarity between two variables, and comparison, we can compare two variables and predictor influence. And into the multivariate analysis, there will be a there will be a multivariable, and we can identify the relation between single uh, multivariable together. Like there are v1, v2, v3 are the three variables, and v1, v2, v3 are the three variables. And for that, this is the matrix is created to and identify the relationship between v1 with respect to v1, v1 with respect to v2, v1 with respect to v3, like all these things. Okay, so we can identify that type of pattern into the multivariate analysis by performing correlation heat map. Then we will see the hypothesis testing. So we know that hypothesis testing is related to the testing on the basis of null hypothesis and alternate hypothesis. If the experiment is performed and we are assuming something, so we need to consider alternate hypothesis also, or it can be either in terms of greater than or less than. It can not be equal. So this is defined in terms of parametric test and non-parametric test. And parametric test can be defined with respect to one sample data or two sample data. And one sample data where we can perform t-test distribution and z-test distribution. And into the two sample data, we can perform independent. We can create the subtypes like in terms of independent samples or paired samples. If the samples are independent, so we will be having two group t-test or z-test, and the samples are paired, so we will be having paired t-test between these two samples. And in the non-parametric test, we can identify the samples in terms of one samples and two samples. If there is only one sample of the experiment, so we will be performing chi-square distribution, Kolmogorov, Smirnov, and Runs and binomial. And if there are two or samples, then we will be performing these distribution like chi-square for the independent samples, and median Kolmogorov Smirnov. And for the paired samples, we will be calculating the sign Wilcoxon or McNemar or chi-square test. So how we can choose the different test? So that is depend on the category, and we are having information in terms of categorical information or in terms of quantitative information. Okay, categorical information can be defined in terms of category like male or female. Okay, yes or no. Okay, and quantitative information or data can be in terms of quantitative quantity. That is measurable quantity. Okay, so we can perform predictions in terms of categorical or quantitative. And in the categorical predictions, there can be outcome variables that will be used using the category, or we need to identify it as a categorical or quantitative. And then on the basis of that, we will be able to identify if it is a categorical, then choose a non-parametric test. And if it is a quantitative, then do a comparison of means test. Okay. And in the quantitative, how many groups are being compared, identify that, and then perform the experiment. Suppose if the groups are two, so we can perform the t-test distribution. And if there are the groups which is more than two, so we can identify how many variables are there. If there is one variable, so we will perform ANOVA. And if there are multiple variables, so we will perform MANOVA. And in the quantitative case, we can identify the data that it is a categorical or quantitative. And if the data is a categorical, that is defined in terms of category, male or female, or yes or no, spam or non-spam. So we will be applying some machine learning algorithm like logistic regression is there that we can use for identifying the category of that data. And we can perform quantitative approach if the data is quantitative, where we need to predict the variables, how many variables are there into the quantitative data. And if it is based on single variable, so we can perform simple linear regression. And if it is more than one variable, so we can perform multiple linear regression or multiple regression. There is a polynomial regression also into the multiple polynomial regression. So that is based on the data or dimensionality of the data. According to that, we will choose the algorithm. Then we will understand the confidence intervals. Like confidence interval is defined in terms of 90%, 95%, or 99%. So we know that it is a range of values. Okay, that is used to estimate the population of the parameter. That is based on sample data. So there can be a population, and from the population we can take some sample of the data. So this is the population, the large circle, and there are samples, which is a small circle into that circle, and we can estimate the range of these samples, or we can take the samples from the population, and then we will be able to identify the confidence level, or we need to understand the confidence level, like we are considering 90%, 95%, or 99%. Okay, for the 90% confidence interval, that will be a narrow interval, and there will be a tail. So this tail, like this is the distribution, like uniform distribution. Okay, in that uniform distribution, these are the tail. We can calculate the Z score. Okay, and and standard choice is there when we choose the confidence interval, like 95% is there, and for balancing this confidence. And there can be wider interval also. If the this tail is wider, we can choose 99% for the higher confidence level. Okay, and if the wider is the interval, so this means higher confidence but lower precision. And if narrower is the interval, that means higher precision but lower confidence. So in that way, we will be able to identify that we need to perform Z score or T score on the given data set. So now, how we can choose the programming concept for calculating these things? So there are many libraries that we can use for performing these experiment into the using the Python. NumPy is there. NumPy is the numerical Python library where we can perform numerical computing. And we need to import that library using import NumPy as NP. And we can use that library by using np.mean for creating the or for identifying the mean value of that data. And np.std, that is used to calculate the standard deviation of that data. And pandas library is also there into the Python programming, that is used to handle the data. So we can import the pandas as PD, and then we will be able to identify the statistics related to that data using df.describe, and we can segregate the columns by using df.group by. That if we want to perform the statistics only a particular column, so we can use df.group by to segregate these columns. And SciPy, that is another library that we can use into the Python programming. And this library is mainly used for the statistical tests. So we need to import that library also from SciPy import stats, and then we can use direct functions to calculate the test on the data using this statistics approach, like stats.t-test underscore ind. That is to calculate the t distribution or performing t-test distribution on the data set, and stats.chi2 underscore contingency. So that is used. This function is used to perform the chi-square distribution for the data set. And we can also visualize after applying the statistics approach on that data set. We can perform the visualization using matplotlib library. So there is a visualization approaches can be done with the help of matplotlib library, which is used to import, like import matplotlib.pyplot as plt. And if we want to create the histogram data or histogram of that plot, so we will write plt.hist underscore into the parenthesis the data. Data will be the variable where we have uploaded the data set, and plt.show to show that result of that figure. And Seaborn library is also used. That is also used to create some statistical plots, and we will use that library by using import Seaborn as SNS. So we can create distributed plot using statisticals or Seaborn, or box plot we can create using Seaborn. And there is another library known as stats model that is used for the statistical modeling. So we can use import stats model.api as SM to create the like least square approach, to create the model in terms of least square approach, and we can create that model using model.summary. Scikit-learn library that we know, that is used for is used mainly for the machine learning algorithms. And that library we can use like from sklearn.linear underscore model import. Here we can give the name of that model that we are using. So suppose if we are using linear regression, so we will write linear regression. And the model can be created using just simple statement model dot fit x comma y. So x will be the there are like data is defined in terms of x and y. So first we are having some data set, and that data set will be split it into the test data, training data, and validation data. So we will train the model on the test data, and we will test the model on the test data, and we can predict the outcomes using on the prediction data. So there are many applications for we can see that we can use the statistical approaches into these applications like disease risk predictions we can use. So we are having large data sets and algorithm to predict the probability of future disease occurrences using statistics. Machine learning can be used into the medical images also. We can apply the CNN, that is the convolutional neural network approach from the deep learning algorithm and to interpret the scans and to identify the detection from the images. So we can apply the statistics on that data also, and we can perform advanced statistical application like we can calculate patient survival analysis. So we can analyze time to event data using survival test to understand the treatment efficacy, and we can use into the pharmacy as a drug discovery on the molecule modeling, utilizing the biometric data to screen and simulate new drug compounds efficiency. And we can perform AI-based diagnosis in terms of clinical decision and using the machine learning and deep learning models. And there is a clinical decision support also that we can use these approaches into that. And personalized and public health we can also use like we to monitor and analyze the disease outbreaks across the population for timely public health responses, and into the personalized medicine like tailoring treatment to individual genetic, environmental, and life cycle profiles. So first, what we can do, we can have some data set, and suppose we are having data set related to the proteins. So maybe there are 240 proteins into that data, and there can be 4 functional classes into that data. So each row in the data set is considered as one protein, and this data set is defined in terms of ID and its amino acid sequence and the class level. So data set is having ID numbers and amino acid sequence information and the class level of that ID. So classes can be in terms of the classes can be defined in terms of enzymes or structural or in terms of transports or receptors. So there can be 16 proteins per class. So a protein per class can be defined in terms of 16. And they are we can see the subscription of these classes like VESTR we use, like AESTR we use. So there can be 16 proteins per class. So enzyme is defined by E and it is used to catalyze the reactions. And structural information is defined by S and it is used to provide the shapes and the support from the data set. Transport defined by T to move the molecules and receptors to receive the signals. So suppose you are having some sequence number, that is the definition of the protein analysis. And the sequence can be defined using BioPython from bio.sequtils.prod import protein analysis. So first we need to import the protein analysis library from the BioPython, and then we can create a sequence. Okay, so this is the protein sequence. So here sequence is defined into the double quote, and then we can perform the protein analysis on that sequence by using the function protein analysis. Okay, and then we can calculate the molecular weight of that sequence and isoelectric point by using prot.molecular underscore weight and prot.isoelectric underscore point. Or we can calculate the gravy as prot underscore gravy, and also the charge, which is giving you the pH level, to prot.charge at pH. Okay, so we calculate these things and we can display these things on the output by using the print command. So we can write like print MW colon point 1F. So that is used to define the float value. Like we have to give this result will give in terms of decimal value, and this is defined again as a dot 2.2 float, 0.3 float, and 0.2 float. So we will be having this type of information in terms of after two numbers after after the decimal, and three numbers after the decimal, and two numbers after the decimal. So you can see the graph, see the result also. So 0.3, 463.3. So this is giving one number after this decimal, and isoelectric point giving you two numbers after the decimal. So like that's why it is written 0.2F, and hydrophobicity giving you 0.3F. Because of that, you are getting -0.632, three numbers after this decimal. Okay, and net charge of PS we are getting 4.20 because of that we have written into the print. So amino acid property groups are defined in terms of their subscription like D or E. D are related to the property group of the acidic, and we can count the acidic component by using this count function. The acid underscore AA count we can use. So we can count the acidic component from the amino acid, and we can count the base component from the amino acid by using this function base underscore AA count, and we can get the information about the polar uncharged amino acid substances using polar underscore AA underscore ratio, and we can get the hydrophobic substances from the amino acid by using this function A polar underscore A underscore ratio. So these functions are already there. Using Python, we can get the information about that data set of amino acid. So next is like we can have proteins which is very enormous into the length. So we need to count the like reflected length from these proteins and not composition. So we can count the reflected length from these proteins. So we need to define amino acid groups so we can get the strings constantly. Okay, so we can create that approach to get the string constantly. And exploratory data analysis need to be performed on the data set. So exploratory data analysis is the part of pre-processing, and in that we can perform like we can get the shape of the data set using df.shape, and we can find out the null values into the data set by using dot is null dot sum. Dot sum is total null values. Dot describe will give you the total statistics of that data, and df dot select d types means you are selecting the data types including numbers. Only include the numbers into the data type to get the numeric data frame, and calculate the correlation by using dot core, and then calculate the correlation between the numeric data by using dot core, and then create that heat map using import cbound as SNS, matplotlib dot pyplot as plt. So cbound library will be able to create the heat map or in terms of matrix, and that matrix size we can give using plt dot figure fixed size equal to 14,9, and heat map can be created as full form heat map for the correlation. So that will give you the result in terms of correlation heat map. So I will show you all these things into the Colab also. So we know that choose the test between Z test or T test. We what test need to be choose into the data set. Okay, so if like we can identify the things related to that. So both tests take the same question: is a sample mean different from a hypothesis value? Okay, and we can use a Z test only if the population standard deviation is generally known. So we will see some things related to that into the collab. So like this is the hands-on exercise. Practice choosing and running the correct and sample test on different protein class feature. Filter the data set to transport the class only, and test whether the mean hydrophobicity differs from a reference value of perfectly neutral 0.0. Run scipy.stat.t test and report the T statistics on p-value and 95% confidence interval. And is transport class hydrophobicity significantly different from neutral? What would that mean biologically? So this is the task that we can use. So we can also compare ANOVA approaches, that is the variation analysis. So in that, we can find out apolar amino acid ratio across the classes. So for that, we are having some stats, like we need to import the stats from SciPy import stats, and we are having some group on the from the data set in terms of their classes. So groups is defined by using their classes. Df dot class equals to C, and a polar underscore under a underscore ratio for C in data frame of the class dot unique to identify the C from the class uh, to get the result, and then show the statistics of that data by using this command underscore stat comma p underscore values stats dot f underscore one way store groups star groups. So we will be able to identify the ANOVA of that groups. That groups is defined in terms of classes with the C. Okay. So we have already seen the class type. What is the class type used for that particular thing? Okay, now next thing we will be understanding the concept by doing that. So I'm opening the Colab. So from this cell we can see. The first thing is that you need to install the library. All the library need to be installed again if it is not installed. Okay, so this pip install BioPython can be used to install the library. And then suppose we are performing the protein analysis. So we will run this cell pip install Python. So all the library will be installed. Then we will import the library protein analysis. So from bio.seq utils dot param import protein analysis. Okay, next, what we can do, define any protein sequence. So either you can define a protein sequence or either you can upload the FASTA file. Okay, protein file, FASTA file. So here we are just taking simple example to show the protein sequence analysis. Okay, create the protein analysis object. Now for creating the protein analysis object, we will use this function protein analysis where P is capital and capital is A is capital, and then SCQ, which is defined already, variables SCQ. Okay, and then calculate the molecular weight. So that can be calculated using port dot molecular underscore weight. Okay, this is not shown so that you can show this by using print command. So which is 808.8575. Now calculate the isoelectric point. So we know that isoelectric point is a pH which is showing the protein when there is a zero net electrical charge. And if the pi or isoelectric point is greater than 7, that is a basic protein. And if the pi is less than 7, that means it is a protein. So these features can be useful for separation into the protein technique to separate the electrophoresis. So we will get pi is equal to prot dot isoelectric underscore point. And then we can calculate the hydrophobicity, that is gravy. So gravy is the grand average of hydropathy. So gravy can be calculated by using prot dot gravy. And charge can also calculated as prot dot charge at pH. So we can see all these things as molecular weight, isoelectric point, and hydrophobicity and net charge. So all things are visible now. Now if we see this advanced concept related to statistics, we need to install all the library and import all the library related to that, like matplotlib, numpy, pandas, cbond, stats model for the multi-computing, stat model for the API, or like collection import counter, scipy, stat model for the multivariate PCA. First, we need to install all the library. Then we will be having some another data set. So that data set is defined on the random value of that seed. Okay, ensure the same number are generated at each time. So we are creating the random value as random by using random function from the np, like numpy library, to np.random, and it is a seed information which is like 9382741. So we can create the data frame with two columns of this random data. So we can define group A that generate 40 random value from the normal distribution, and this is defined as group A stats.non and LOC, which is the location and scaling, and also the size of that randomly generated data. Then group B is also created by using pd.data frame that is showing stats of non. Okay, and scale, that keyword specify the standard deviations, or LOC define the mean with this value. Now create a categorical strip plot using cbond. So we can create the categorical strip plot by cbond if we want to create. And if you want to create a box plot, the box plot can be created by using cbond library. Cbond library is used to calculate the various different types of plots. The box plot is comes under the cbond library, not matplotlib library. So that's why it is written as sns dot box plot. And for what we are creating the box plot, we are creating the box plot for the df data frame, which is already defined in terms of A and B data, B types of data. Like this is group A and group B types of data. Okay, and width of that box, what should be the width of that box? So it is defined as 0.25. And color we can provide by using hexadecimal values. So there are many values that we can choose to creating a different types of colors into that. Fill is equal to false. When now for that data we have created, and then we have converted this data into two groups, group A and group B. Okay. Now we can perform unpaired t-test comparing between group A and group B. So this can be performed using stats.t-test underscore ind, and it is used to perform the independent sample t-test. So we are know that we are having two samples into the data frame, sample for the group A and sample for the group B. So now what we are doing, we are creating the t-test like using its result is equal to stats.t-test underscore ind, and group A data frame or and comma group B data frame dot p-value. And we can also calculate the mean value for both the groups by considering df dot mean. So by considering df dot mean, we can calculate the mean value of both the groups and then display the means. So we can calculate, we are able to calculate the group A and group B mean value, and it is showing unpaired t-test B value also, which is 1 point into 10 to the power of minus 3. Next, we can see that we are having uniformly distributed two groups, group A and group B, from the randomly generated data, and we can create the plot of these groups as using Seaborn library as sns.cat plot, that is a categorical plot, and sns.box plot. For what? DF, data frame. So this is the DF, data frame. And height for category 3, and aspect ratio is 1.6. And for the box plot, the size of the box is 0.25. Okay, on that cell we were done. So now you can see that we have created this plot for group A and group B. So this blue color is for group A and this orange color like for the group B. Okay, the color we have already provided here. Which color should be there into the sns.box plot and sns.cat plot. Now we can perform the another test using the Python programming, and that test is known as the Mann-Whitney test. So this test is also used to compare the between group A and group B, and from that test we can get the p-value from the test result using the function result is equal to stats.man with new df group A comma df group B dot p-value. Okay, so then calculate the median value for each column into the data frame by using pd.dataFrame df.median comma columns is equal to median. So this value we can see as a result. For the group A, we are having median 8.41, and for the group B, median is 12.91. And Whitney test p-value is 0.03. Reproducibility, we by changing the seeds information, and we can create the random seeds from that for this data. And before the terms of mean and variance. And first we will create the data frame with two columns. And pre means the pre-treatment measurement, and post means the pre-treatment value plus a small random effect on that treatment value. And with mean is equal to 2 and standard deviation is equal to 1, we will write the function as pd.dataFrame, pre for before the treatment and post mean before the treatment plus stats or normalized value for the mean is equal to 2 and standard deviation is equal to 1. So we will be able to create the strip plot that is used to show jittered point to visualize the individual data points, and that will be the strip plot to show the data visualization into these two groups, group A and group B. So SNS.boxplot is used to create that box plot. SNS.cat cat plot to create that categorical plot. Now we can run the t-test also. So t-test can be run by using the stats.t-test under rel, and for on what pre and post pre and post. So there are two variables we are considering, pre and post, and we are writing the t-test or we are calculating the t-test on that pre and post. So stat.t-test underscore really df for the pre and comma df for the post dot p value. And also we can calculate the means by using pd.dataframe df.mean, comma, columns is equal to mean. We can show the results by using the print function f unpaired t-test value. Now suppose another seeds are created, so that is for different thing. And we are considering randomly generated seeds as 42, and number of patients we are assuming that 200, and data set is having some information about the patient like patient ID, age, systolic blood pressure, cholesterol, it is person is cholesterol or not, and treatment group. So treatment group means the person is placed on a drug A or it is placed on the placebo. So patient ID is defined into this square bracket F double and then double quote P underscore ID number for I in range 1 comma n underscore position plus 1. So read all the IDs by using this command. And age column means you are having age information as a one column, and that is also randomly generated information here. We are not uploading any data set, and in that mean and variance is given for n number of patients. Cholesterol information is also given. Treatment group is divided into the group drug A. I mean that means you are giving the dosage A to that group, or it is placed on to the placebo. Okay, next we can create the data frame of that data set. So using pd.data frame, we will be able to create convert this data into the data frame. And when the data frame is created, then we will apply some stats on that. Suppose add a simulated disease recovery score based on treatment and age. So we can get the recovery score or disease recovery score on the basis of the treatment and the age of the person. So we can create the df into the square bracket double quote recovery score is equal to, so 50 plus df. Df is for the treatment group and equals to drug A multiply by 12. We are providing this drug A to that group, and minus df age multiplied with 0.2 and np dot random normal 0,5 size is equal to n number of patients. df dot head. So you will be having this type of information from after running that. Patient ID is there, like this is the serial number and this is the patient ID and this is the age. This is the systolic blood pressure, cholesterol level, and treatment group like drug A and placebo-based group, and recovery store or recovery score. We can display the summary or statistics by using the command plt.figure, and figure size we can create using 10,5 to generating the figure of that size. And histogram plot we can create using SNS.histplot. And histogram plot can be created between recovery score and can be created for the recovery score. So we can create the histogram plot for the recovery score of size KD true and color is sky blue. And these commands are for distributing just showing the title on that plot, and X label just to show the things on the X-axis, Y label just to show the things on the Y-axis, PLT to show the result. So this type of graph is created by using this command. So here you are getting this print DF, age, systolic blood pressure, cholesterol, and recovery score. And you are getting another plot distribution. Okay, so in that you will be able to identify the summary in terms of statistics by using df.describe of that given data, and then you can create this histogram plot. So recovery score is given on the x-axis and frequency is given on the y-axis, and we are creating this histogram plot with these commands. Okay, between recovery score, and this is showing just for the recovery score only. Next, calculate the point estimate and confidence interval. So we can estimate the point estimation technique. We can perform the point estimation on using the statistical approaches on the given data set, and we can find out the statistics related to the confidence interval. So mean score can be calculated as np.mean df, that is the data frame for the recovery score. So recovery score mean is calculated by using this formula, and we can get the standard error of mean, that is known as SEM. So SEN is the standard error of mean. We can calculate by stats.sam df for the recovery score. And 95% confidence interval using t-distribution is calculated by using stats.t.interval confidence is equal to 0.95, or data frame length is given as data frame minus 1. And LOC is the mean score, and scale is the uh, like standard error of mean score. So we can show this mean score and standard error of mean score by using print command. Now we can perform the hypothesis testing on that two groups. The group which is provided drug A, and group B which is on placebo. So drug A, we are considering the treatment group for the drug A, and to getting the recovery score, and placebo for the treatment from the treatment group to get the recovery score, and perform independent t-test on that data by using stats.t-test_ind for the drug A, this one, and placebo. So in the printf, we can get the information about using the t statistics and p-value from this formula. So we will be having p, and then we will check if p-value is less than 0.05 colon print this result is statistically significant and drug A has a significant effect. Else print no statistically significant or difference detected. We can create the plot for the comparison using the SNS.box plot between the X and Y. X can be the treatment group and Y can be the recovery score. So like this type of graph we can create. This is known as the recovery score by the treatment group. So now we can can perform multi-group comparison also. And comparison means across three or more groups. Like multi-group means we are comparing one or like more than three groups. Yeah. Okay, so that we can do in terms of low, medium, high dosage levels using ANOVA. Suppose we can create three dosage groups for the demonstration. One dose is as low, and another dose as medium, and another dose as high. So we are creating that group for the dosage level in terms of low dose, medium dosage, and high dosage. So we can perform the ANOVA on the disease level to get the recovery score for the low dose, dosage, medium dosage, and high dosage. Okay, then we can get the F stats or P value of ANOVA using this function stats.f one way low, medium, comma high. So that is the that is the statistical functions, which is stats. Print ANOVA statistics now. So we can get the ANOVA statistics in terms of F statistic and P value, and then we can visualize this ANOVA group. So visualize can be done using Violin plot. So we will write SNS dot Violin plot X for the dosage level, comma Y for the recovery score, comma data is equal to DF and order is equal to low, medium, high, which should be written into the list form. Comma palette is blues. So then we can provide a title, and also we can provide a X label and Y label to show this graph or result. So this is the like graph we have created to showing the dosage level in terms of low, medium, and high. So that graph is known as the palette. Okay, so this is created like this, showing the recovery scores across the dosage levels. Now we will see some categorical data analysis in terms of chi-square test or independence using independent, which use the chi-square test to determine whether two categorical variables are independent. Okay, so there can be the example related to the treatment group and readmission status. So we can identify the categorical dependency on that variables by using chi-square distribution or chi-square test. So, like suppose there is a simulated categorical outcome that a patient are readmitted within the 30 days. Okay, so this can be defined in terms of yes or no. That patients are readmitted within 30 days, yes or no. Okay, so we can use data frame for the readmitted is equal to np.random.bio on binomial 1 comma props. Okay, so and then we can get the map in terms of yes or no information that they are uh, readmitted within the 30 days, yes or no. Okay, so we can see the in terms of graph. For that, we can create the contingency table. And then print this contingency table. Perform the chi-square test as chi2, comma p chi2, comma duf, comma expected is equal to stats dot chi2 underscore contingency table. So this contingency table is there as an output, and we can see that patients are readmitted, no or yes is written here, and treatment group. If the patient has given drug A, so they have not readmitted, like 78% are not readmitted, but 25% are readmitted. And if the patients are placed on the placebo, so 51% are not readmitted and 46 are readmitted. And if we see the significance of that value in terms of p-value and chi-square statistic, we are getting this value. correlation and covariance analysis. So we can see that correlation is also performed on comparison between or finding the degree of similarity between the two random variables, and covariance is also used to identify the variance between two random variables x and y. Okay, so we can evaluate the relationship between the continuous variables and using Pearson and Spearman correlation coefficient. So correlation matrix, we need to find out we need to compute the correlation matrix, and correlation matrix is defined in terms of data frame as age and systolic blood pressure, columns name, which is already given into the. So we can use .curr, that is the correlation function, to get the correlation between these variables. Okay, as a Pearson and Spearman correlation coefficient. Then we can show this Pearson correlation coefficient using the print, and we can create that correlation matrix writing into the print. And for creating that figure, we will use C1 library SNS.heatmap. So SNS.heatmap is there to creating that correlation matrix to create that figure, and it can be visualized using plt.figures for the figure size, and heat map is created on the data correlation matrix, this one, and it is a type of cool warm, like we can give another name also. There are so many things for that you can choose. So it is loading. Okay, CMAP information you can get from the Google also after searching that. If you want to display this uh, result or matrix in the different format, so we can choose that part only. And what we can write, we can get the information from the searching. What we can use CMAP from the help. Okay, and title we can provide like correlation matrix heatmap and plt.show. So this will give you the results in terms of correlation matrix heatmap like this. So you have created this matrix as a Pearson correlation matrix between age, systolic blood pressure, cholesterol, and recovery score. And then you have shown this in terms of a matrix. You can see that one means there is a similarity, almost similar. Almost mean exact like age is written here. These are similar. Systolic blood pressure or age, so they are like they are similar to like 0.09, 9%, 9.66%. So systolic blood pressure depending on the age, 9%. Cholesterol is giving you negative result. Recovery score giving you negative results. So this is the way of getting the this covariance and this correlation coefficient heat map matrix. Next test we can understand that is related to the strain U test. So when sample data is non-normally distributed or contains significant outliers, so we will choose this test, and this is the non-parametric test, like the Mann-Whitney U test. So we will replace the standard T test with the non-Whitney U test. So in that, what is there? Like you can use stat non, P non, and function you can use stats dot Shapiro on the recovery score. Okay, and then show that result as Shapiro Wilk normality test p value by writing this p norm here with 0.4f. And also you can perform Mann-Whitney U test on the non-parametric equivalent of independent t-test. So that will be like stats.Mann-Whitney U. And you will provide the input as drug A and placebo. So we are conducting this test that is known as Mann-Whitney U test on the drug A and placebo using this function. Then show the results and output by using print function. Then you can run this, you will get this results like this. So Shapiro will normality t-test p-value, we are getting 0.0457, and Mann-Whitney used statistic, we are getting this p-value, or Mann-Whitney, we are getting this match. Next, we can see the binary disease risk predictions. So binary disease risk prediction can be calculated with the help of logistic regression. When there is a thing related to binary, so we will use logistic regression analysis, that is the part of machine learning algorithm, into the supervised machine learning model, logistic regression. And it is used when there is a binary type of outcomes we needed, like yes or no, true, false, 1, 0. Okay. So this type of model binary classification outcomes will be in terms of predicting high risk versus low risk of hypertension based on clinical metrics. So depending on the blood pressure, we will find out that it is a low risk or high risk. That will be a categorical outcomes. So for high risk BP, take the systolic blood pressure and consider if it is greater than equal to 135. Okay. So that will be a high risk BP. And then create the model using smf.logit for the high risk BP, plus include the cholesterol into that model, and then show the results as a summary, dot summary. The dot summary is used to get the model information, and calculate the odds ratio also, like np.exp to logit underscore model dot parameters to show the prints and odd ratios. So these values we are calculating. Okay, like optimization terminated successfully. Current function value is 0.67, 0.967, and total 4 iterations are performed for the logit regression results. And dependent variables on high risk blood pressure. Model is logist. Method is MLE. That is a maximum likelihood estimation. Dated, time, converged, or that is true, or covariance type non-robust. Number of observation 208, residual 197, and pseudo R square value, log likelihood value, or LL null value, or p value. And also we are able to find out this table for the intercept, age, and cholesterol on intercept, age, and cholesterol basis for the coefficient, and for the standard deviation error, for the z value, for the p value. So now, if you want to drive comprehensive real-world clinical insights into the healthcare data, okay. So there are multiple quantitative approach that we can use to perform these testing. We can perform descriptive profiling. We can perform hypothesis testing. We can perform predictive modeling, and we can perform survival analysis into a unified analytical pipeline. Okay, so in that we will see all these things. The first approach, suppose if there is a dimensionality reduction and plus unsupervised clustering use cases. So dimensionality reduction is an algorithm which is used to reduce the dimension of the data set. Like suppose you want to reduce the data set variables from 3 to 2. Okay, like there can be multiple dimensions, and you want to reduce the data dimensions, so you can perform some discriminant analysis like LDA, which is used to perform which is a mathematical algorithm to get the reduction into the dimensionality. Also, there is another algorithm that is known as PCA. So PCA is the principal component analysis algorithm. Okay, and that algorithm is a mathematical approach, and it comes under the supervised machine learning approaches. So that is also used to to create to reduce the dimension and identify the features from into the data. And then there is another algorithm that is known as And K means clustering algorithm. That is the part of unsupervised machine learning algorithm, and it is again a mathematical algorithm. And this algorithm is used to identify the various clusters from the data. So we can divide the data set in terms of different subpopulations with the help of K-means clustering. We can propose another approach we can propose another approach related to K-means or hierarchical clustering. So these are the two machine learning. Either we can use K-means or hierarchical clustering, depending on the and then we can validate this using ANOVA that is used to identify the feature difference between the newly and discovered algorithm PCA from the machine learning. Supervisor is the library that having to import this library. That is a sign of PCA is imported from the SQL unsupervised machine learning algorithm. So you need to know that what is supervised and what is unsupervised. So supervised means there is a labeling into the data. The data is labeled and you are having some input and you have to achieve that some target output. So that means though you are labeled. Okay. And into the unsupervised, data is not labeled. Well, that means you are not having defined data and you have to just predict the outcomes. So these in that way, the machine learning algorithm is divided into the supervised and unsupervised. And the K-means is the part of unsupervised machine learning algorithm. And we are identifying the features from this data as age, systolic blood pressure, cholesterol, and recovery scores. Okay, so scale these features by using X scale and get the value of the data frame as features and minus TF features dot mean. Like subtract the mean value from all the features, and then divide the with the features value of their standard deviation with the feature value. Okay, or then you can apply the PCA directly. This is the formula of applying the PCA on that n components, which is defined as 2. So we can create the model by using PCA.fit transform axis on the X scale. So model is created on that X values to transforming this data into the features, into the PCA features, and then clustering is applied. So K means we can use for applying the clusters. A number of clusters we can create 3 into the clustering approach, and random state taken as 42, or number of iterations taken as 10. Okay, so we can visualize this clustering after creating the visualization code. So plt.figure size 8,5. We are creating a scatter plot. So that's why it is written as SNS.scatter plot for the PCA transform, and title, label, y label as we can provide as per the choice, and then we can run this code. So you will be able to identify these cluster like this. So patient is a phenotype clusters having 2 approaches, PCA plus K means, and these are the patient cluster 0. Red color cluster are defined as 0, and blue color cluster are defined as 1, and green color cluster are defined as 2. Okay. Next, we can also understand the propensity score matching, or we can apply propensity score matching with the regression analysis in observing the studies related to the randomly assigned treatment groups. Okay, maybe older patient might be more likely to receive a new drug, or maybe like there is a randomized control trial. Okay, so by matching the treatment and untreated patients with similar baseline characteristics, we can assess the treatment efficacy. The combined workflow related to logistic regression, and that is we are using for estimating the probability, known as propensity score of the patient who is receiving the drug A. And based on that baseline characteristics, we are using two features, age and blood pressure. And for the nearest neighbor matching, we are matching the treated patient with a control patient having a similar prosperity score. So there we can find out or identify the pair-T test or linear regression to estimate the true causal effect on the matched subset. So that we can create using that to create a binary target variable 1 for drug A and 0 for the plasma. First, you are considering that drug A is for the binary target variable. We are defining drug A as 1 and placebo we are defining as 0. Okay. So in that data set, treatment group can be equal to the directly drug A. Okay. If it is a type of integer, and then we can apply the logistic regression model using the binary target variable on that data. So smf.logit is drug A, and this is the tilde sign that is used to define as not age plus systolic blood pressure. Data is equal to df dot fit this is equal to false. So this here we will get the prosperity score in terms of the propensity model on the logistic regression of the on the patients, those who are getting drug A. And we are considering two parameters here as age and systolic blood pressure. So we can show the results in terms of the distribution of propensity score by using KDE plot. KDE plot we can create like this. So this is the KDE plot. So this is the propensity score between or propensity score overlap between the treatment groups. So that is blue is related to the drug A, and this part is related to the placebo, and this is the overlap group. Next, we can use Kaplan-Meier survival curves plus Cox proportional hazard model to estimate the survival analysis of the patient and understand the outcomes in terms of like healthcare, like knowing when the outcome occurs to identify the disease recurrence or hospital readmission process. For that, we can use combined workflow Kaplan-Meier estimation approach that is used to visualize survival probabilities over the time across the patient cohorts and log rank test to compare the survival curves statistically between the groups. The cog regression model is there for that type of approach. And here we are finding the empirical survival curves by the treatment group using the Kaplan-Meier curve visualization. Bootstrap resampling is also there that we can also use. I think time is left. Okay. So many things are there that we can perform into the statistics also. And I covered only the important things. Okay. So we will be doing more things if any other workshop will be conducted into the future. Now, next thing that was left into the yesterday class that I will cover. And I will show you some in the last class, the thing was left, which is multiomics. Okay. So what is multiomics? So I will show you these things. First, I will finish this website and this PPT. So there is no thing left that we have already covered into the practice part. And today I'm not showing the hands-on because if I write the code and then I will get the result, so it will take more time. So that's why I have shown you the results and the codes, that approaches that we can use. histogram plus KD from feature prediction to random forest, confusion matrix or feature importance we can get, and we can get full protein statistics pipeline after understanding all these things. Like we are having sequence data, we can perform feature engineering on that, and we can apply the EDA on that data, perform the statistics using hypothesis testing, ANOVA or t-test or z-test, Welch-ANOVA, Kruskal-Wallis. Okay, and then perform the prediction using random forest classification or using validated features approaches. Okay, next, I think the thing which we have left into the last class. So this is my work that I am currently doing. You can see here to get the understanding of the drug repurposing. That is the concept related to the drug repurposing. We are combining the drugs. Like the data set information is given here. So I will show you my work also and can share with you. So I'm writing the paper on that. That's why I'm not showing all the things. But just can give you the basic info related to that. And I have done some projects related to like lymphoma cancer. And this project is related to the imaging data. So lymph image data set I'm having, like benign image data. And these are the data sets that I'm having. And I have also published one paper on IEEE conference on that. So this was the paper I have published. Transfer learning CNN approach for enhanced lymphocyte classification. So I have just given the classification approach, apply the classification approaches on that. Like on data set, I'm having that lymphoma image data set. Then I performed the pre-processing and image augmentation technique on that data. Okay, and then applied the CNN architecture, and then applied the transfer learning approaches from the CNN architecture, and then compared these all the approaches, and then results are calculated in terms of accuracy, precision, recall, abundance score, ROC curve, AUC curve. So this was the conference small paper, so that's why it is written in a very not in very detailed information. Okay, and I will show you some other thing also. So multiomics, I think, was left into the last class. Okay, multiomics. So we know that what is multiomics. It is like there are many types of information we are having. Omics means large scales. Okay, so we are having genomic information as a DNA. We are having transcriptomics information as a RNA. We are having proteomics information as a protein. We are having metabolism information as a small molecules, and epigenomics information as a regulation. So multiomics means measures several of these layers. Like you can use all these layers together on the same samples, and you can find out the tumor biopsy profile for both gene expression and DNA mutation. And no single omics layer tells the whole story. So like no single layers you can use for getting the good results. you need to use so many layers, like you need to use so many things related to that. So that is known as multi-omics, where you are considering many informations. Okay, and in that, suppose you are having genomics data, transcriptomics data, proteomics data, metabolism, genomics data. So you can integrate through the AI. You can integrate them through the AI, and then you can use these integration to create establish your research into the biomarker discovery, disease prediction, drug discovery, and precision medicine. So I will show you a slide. Okay. So there are so many applications that is use multi-omics data. Okay, you can combine these data sets together to perform multi-omics information. Like there can be clinical data. Clinical data are stored into the electronic health records, or they can be stored into the lab results, or they can be analyzed using the lifestyle and environmental conditions. Okay, you're having these data like genomic data, transcriptomics data, epigenomics data, proteomics, metabolism, microbiomics, immunological data, single cell data, circulating biomarkers. So these are the molecular and omics data. And these are the clinical data, which is electronic health record and lab results. And these are the imaging data, like anatomical imaging, functional imaging, molecular imaging, optical imaging, and microscopic imaging. So we can use these data together to get insights into any disease. Okay, because single information cannot be used to identify the disease condition. We need multiple information from the patient. So that's why there is a concept of multi-omics. And in terms of AI, we use this concept as a multi-model analysis. Like suppose X-ray image is there, and electronic health record is there, like prescription of the doctor or the person, patient provided from the doctors. And also suppose the results is given in terms of ECG. That is, ECG is again uh, text information given in terms of file. Okay, and also you are having some gene information like DNA information of that person. So you can analyze the disease condition by merging these things. Okay, so that is known as multimodal analysis. Like currently that we are doing this into the AI, and this is now it is a current topic of research, multimodal analysis, where you can see that so many people are using ChatGPT. They provide like electronics health record to the ChatGPT, and then ChatGPT, what ChatGPT can do, they and this the ChatGPT analyze and combination of these things, and then it will give you the suggestions and results. Okay, so models can be developed in that way, where we are using the different things together. Again, we can create this with the help of Python. So in the Python, we know that there are so many libraries that we can use. But now, if we are using for the research purpose, and if we are using this for the advancement into the research, so we need to understand more things, not simple Python library or not simple Python concept. We need to get insight into the more informative way. Like we should know LLM, and that is a large language model. We should know generative AI, that is used to generate the images, generate the audio, generate the video. And we should know agentic AI, that is used to perform the automatic task. Okay, and into the multimodal process. Okay, and then we will be able to identify the things together. The core data structure can be understand using the annotated data object, like per sample metadata. We are having patient ID, conditions, and this is defined in terms of variables. Variables can be identified in terms of features like gene name, chromosome, and this is related to the genomic analysis. There can be combined genomes in terms of proteins, in terms of DNA, RNA. Okay, but in case of multimodal analysis, the data can be related to so many things. Like it can be audio files, video files. Suppose somebody is working on the brain disorder, so they are also having the audio files of that person, or they are also having the MRI images, CT scan images of that person. So they are analyzing together, or they are also having electronic health record. So they are analyzing these things together to understand the disease, to get the most best uh, treatment to that particular disease. So this is again related to multi-omics data, that how we can perform with the help of Python. So what is the things that in the early stage, like strategy, we choose early integration. So how it works is concatenate all the omics matrices into one large feature table before the analysis. And trade-off may be related to the simple, but different scales noise across layers can be dominate the results. Similarly, if there is a late integration, or there is an intermediate integration, or network-based integration, we can also interpret the biologically dependent results using that. So this is the like practice exercises that we can do. And this is the one case study that we can perform using how multiomics redefine breast cancer subtypes. So cancer genome atlas can be defined in terms of TCGA, that is a profile thousands of tumors across the genomics and transcriptomics and proteomics layers. And these all are freely available for the research and teaching. And these transcriptomic clustering identify the PAM50 molecular subtypes like limonil, AB, HER2 enriched, and basal like group that is invisible to the histology alone. And each subtype shows a distinct combination of mutation, expression patterns, and protein markers. And this same scanning or annotated data PCA clustering workflow applied to the real TGC data. And how the multi-omics analysis workflow? First, you need to understand the data, load the data, identify identify the things from the data using applying the remove the low quality samples and the features from the data, normalize the data using performing the things related to the scaling and log transformations, and then reduce the features from the data using the PCA or UMAP and clustering approach, and then test by using differential expression, and then interpret in terms of enrichment or integration. So this is the thing that I am suggesting you for research. Like you can do that also. Okay, I will also try to complete this because I am doing that, but I'm not completed. So into that, you see that from the patient, we are having some images like pathological images, and we also are having RNA sequence expression from the single patient, or we are having proteomics protein labels. Okay, so we can apply vision transformer approach to get to visualize these images and to get the insights of that image. So these are the histopathological images that can be analyzed using the vision transformer. That is a deep learning model. Okay, and RNA sequence analysis can be used to convert into the sequence of omics encoder. Okay, and similarly, proteomics protein label can also be converted into the omics encoder, and then use all these data together, perform the cross model attention, and identify the graphs to converting these into the graph transformer. Then the classify the cancer type, like it is also its subtypes, and then apply the SHEP and GradCam approaches to clear more precise or clinically precision based image. Okay, so that is the GradCam approach to get more correct information in terms of visualization, and SHEP approach. So that is the explainable AI, where we can use SHARE plus GradCam approaches to get the more better results in terms of visualizations. Okay, so We have already discussed about the data sets also, databases and next step, like from where we can get the data sets. Okay. And what type of information we can use to perform or developing these models. Like ensemble model we can create. Ensemble model means you can create one model. You can compare. You can add one model with another model to create another model. That is known as ensemble approach. So for today, this is from my side. Okay. So I have finished time, I think.
Thank you so much, sir. If anyone have any query regarding the session, please share their questions. मुझे नहीं लग रहा कोई है. We do not have any question, sir. So please, so I am proceeding from here. Thank you so much, sir, for such an insightful and engaging session. Your comprehensive presentation on statistical inference and hypothesis testing using Python has equipped the participants with valuable practical knowledge and analytical techniques that will greatly enhance their research, data analysis, and academic pursuits. Your clear explanation and hands on approach have made this session both informative and inspiring. We sincerely appreciate you for accepting our invitation and taking the time to be with us. As a token of our gratitude and appreciation, we are pleased to present your certificate of appreciation and a virtual memento. This token of appreciation will also shared with you shortly. This is the certificate, sir.
Yes, thank you so much. Okay, so if anybody is having any doubt or any question, if they want to work on these topics that we have discussed, okay, they can contact me by through your organizations. Okay,
Sure, sir. This
you
one
can.
is your memento, sir, which we are showing on the screen. Thank you so much, sir, for joining us and for your valuable time and your excellent session. We deeply appreciate your contribution to the success of the faculty development program and look forward to your continued association with us in the future. Thank you so much, sir.
Yes, thank you so much. We will be conducting more session into the future also.
Okay, thank you so much, sir, for joining. As we come to the close of day 3 of our faculty development program, I would like to thank each one of you for making today's session a great success. Today we had a great session on machine learning, IoT, and big data in public health and food system, and statistical inference and hypothesis testing using Python. On behalf of the organizing committee, I extend our heartfelt gratitude to our speakers, Dr. Richa Gupta and Dr. Naved Alam, for sharing their expertise and enriching us with their valuable insights. I also sincerely thanks all the participants for your enthusiastic participation and active engagement throughout the day. We look forward to welcoming you tomorrow at 11 a.m. for another exciting day of learning. Until then, thank you once again for your participation. Have a great day. Thank you, everyone. We will see you tomorrow.